Welcome to Friday of first week. Today and in class, and in the problems, we're really focused on thinking about how to interpret graphs. Okay, graphs are incredibly useful tools. When we use them effectively, they can really help us solve problems. So one of the things that we're going to focus on today really is thinking about how to go from one graph, say of position versus time, to velocity, or vice versa. Okay? So one of the important concepts that I want you to think about is the difference between instantaneous velocity and average velocity. So when I think about instantaneous velocity, I think about the slope of a graph of position versus time. Here's what I mean. Let's sketch out a possible position versus time. Okay, so I'm going to draw a graph here, straight as I can. This is going to be the position, x, the x position, as a function of the time. And let's say, for arguments, I don't know why the motion will look like this, but let's say that the position starts really high, kind of dips down, kind of does this, and sort of flattens out. We want to think about what the instantaneous velocity is. Instantaneous velocity is the slope of this graph at each point. So instantly, what we're going to do is we're going to look at the tangent line. So for instance, if we want to know what the slope was here, that would tell us what the velocity is there. So I draw my point, I grab my trusty meter stick, and I draw a straight line. Okay? So in this case, the velocity would be negative, and it would be a moderate value. Whereas, if I wanted to look at what the velocity in the x direction was down here, do the same thing, draw my tangent line, good line here. What we'd see here is that the slope is 0. It's a straight line. And this makes sense because at this point, the x position is instantaneously not changing. Now, contrast this to the average velocity. We clearly see that the velocity over here has a negative, the graph has a negative slope, so the velocity is negative, 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 approaching 0, get to 0, and then over here, let's say at this point, if I do the same thing, my slope would be positive, therefore my velocity is positive there. So my graph has a negative velocity, 0 velocity, and positive velocity, at least where I'm looking. But if I were to look at the average velocity, say from here, call this x1, and here, I'm sorry, this is t1, I apologize, to here, this is t2. Well, those correspond to the same x position. So if I want to know what my average velocity was, the average velocity, this is going to be my displacement over my time. But because I'm at the same position in both places, my velocity is going to be 0. And whatever units we're working in, meters per second, feet per second. And so clearly, I have a difference between my instantaneous and my average. Make sure that you really work to try to cement these ideas. From these ideas, though, we can extract quantitative information about the velocity of an object from its position versus time graph. So in this example, we see that we have a student moving in the x direction. And if we want to calculate what the average velocity is in various regions, we do rise over run. That is the change in x over the change in time. And so we can compare how the motion changes at different times. So in these examples, again, we're quantitatively extracting delta x and delta t in each one of these regions. Now, one of the things that I strongly encourage you to do is to try to make sense of the relationships between the position versus time and the velocity versus time. From that same graph of position versus time, what we have in this example, and I encourage you to take a look at this slide or pause the video, we have 3 different regions that we're trying to calculate the velocity. And so in each one of those segments, we associate the motion having a particular velocity, and we create the velocity versus time plot from that position versus time. Try to align your plots the way that we're doing it, right? If you notice, the x velocity is lined up in time with the position. This will help you try to make sense of the types of relationships that will help as you try to sort out the different kinds of motion. Now, one of the other things that we're going to be doing is thinking about accelerations. So, I like to keep track in my brain of how to get between the various quantities. So for instance, if I wanted to try to figure out if I have a position versus time graph and I wanted to get the velocity, well, how do I get there? Well, if I want to go from position to velocity, that's the slope. I take a plot of position versus time. I take the slope everywhere, and that's my velocity. But then if I want to get to the acceleration, well, that's how quickly the velocity is changing. So, I want to get from here to here, again, that comes from the slope of the velocity versus time graph. Now, I can work in the other direction. If I know what my acceleration is, and I want to get my velocity, well, oftentimes this is a trickier transform. Okay? Because in order to get from here to here, I need to calculate the area under the curve. Similarly, if I want to go from velocity to my position, it's the same thing. I need to calculate the area underneath that curve. Okay? So, you're going to have to get used to this. Again, practice will really help. When you think about the area under the curve, let's do a simple example. Okay? Let's say that this is my velocity versus time graph. What I want to do is I want to calculate what the position versus time is. And let's say that this graph looks something like this. This is 0, and my velocity versus time graph looks like this. It's a straight line. So velocity is changing as a function of time. Well, if I want to know about the position, let's call this some intermediate time. Let's call this t1. Well, the area in this region is positive because it's above the velocity is equal to 0. So I would add up that area. But keep in mind, though, that if I wanted to know what was happening over here, this area over here, well, that's negative area. I subtract that. Note, this makes some sense because the velocity is going to be negative in these regimes, or in these times, okay? So you may be thinking about area as being only a positive thing, but in the context of the mathematical transformation, it's not. Okay? Work the problems. Make sure you come to class having practiced some of this. It's going to take practice, okay? It's going to take work. But we're going to figure it out together, okay?